Hi everyone, I just want to welcome you to the first Lunch and Learn for Technical Service this spring. We're going to cover two topics today. One is going to be the charge calculator and how that's going to apply to you guys in the field. And we're going to run through a couple examples of that. The next thing we're going to look at today is going to be the new charging charts that are going to be on the inside panel of the new condenser models. So we've kind of modified the charging chart, if you will, from a curve to a table. So we made it a little more accurate for you guys as a reference point, but we're going to take a look at those two things today. So first thing is, how do we get to the charge calculator? One, we just go directly to the web. It's a web-based application, so you have to go like to Google or Safari on your phone, type in chargecalculator.com, and that will get you directly to the website. Now, once you're there, we just require two things. One, an email address and a zip code on where you're using the charge calculator. So those are the two things that we require, and it'll get you logged into the calculator. Also too, it is smartphone friendly. Basically, we've designed this as if it was an app on your phone. So it's very easy to use, either like on your actual cell phone, or if you have a tablet, it works on that too very well. Also too, so we've had applications where we have microchannel on the inside and tube and fin on the outside. So the calculator, from what we worked on, was combining the two types of coils and trying to get you guys an accurate charge number, because usually in the spring and all through the summer into the fall, we have a lot of charging questions. And but basically the calculator has both technologies built into that. So we'll look at that in the example where you can select, either microchannel indoor and a copper tube and fin outdoor, and go from there. But basically, the charge amounts are based on an average. So for example, if you don't know the charge level or the charge amount that is supposed to be on that unit, like if you don't have the QRD, for example, if you just pick a tonnage, like say 3 ton, for example, we've averaged all of the 3-ton models, whether you select heat pump or air conditioning. I mean, those would be separate, but if you selected, microchannel to microchannel on your equipment, and you picked 3 ton, it's going to average the charge out for all the 3-ton models. So it's very, very close. It's not 100% accurate when you don't know the charge level. So that's why I recommend getting the charge level on that. Okay, so when you're using the charge calculator, one thing that we want to make sure is that we have an AHRI match. So that is very critical, because if we don't, the charge calculator is not going to work. So just make sure your system's a match. If you don't know if it is or not, look on the QRD, or you can go to AHRI's website and look at that information. But one, we want to make sure it's a match, or it'll just be a complete waste of time. Also too, a big thing is the airflow. So make sure the airflow is set right, because there's multiple things that will affect your charge numbers, your pressures and your line temperatures, stuff like that, when we're calculating charge. So in the QRD, when you have your matching system, we give a recommended airflow setting, and basically that's what the matching system was tested at for airflow, and that's kind of where we get the charge numbers, as either you're correct on your charge, or you may be low or something like that. So just make sure your airflow is set correctly, or as close as you possibly can. So also too, just verify that the metering device is correct, because sometimes based on your matchup, you either have to change the piston on the indoor or the outdoor, or sometimes we actually have you add a TXV on the inside. So one, just make sure that your metering devices are all correct, because again, if they're not, the charge calculator just doesn't know that. So, and then also too, a big one, airflow is not factory set. So we have no idea where the units are going to be going and what application they're going to be put in. So you always have to set your airflow. If you have a fixed speed or a variable speed motor, you have to set the dip switches on the blower board or the air handler board for that. And also too, you want to set the blower up if you still have, or you're still using a PSC motor. You just want to make sure you set the correct airflow on that. Look at the blower chart and just make sure those switches are in the right position. Also too, the QRD, if it's not available, like if you can't pull it up on your phone for whatever reason, or you just don't have it, one thing that you can do on the charge calculator that I kind of touched on a little bit is we calculate the charge based on the tonnage. So it's not super critical that you know what the exact number is for your charge. It does help your scenario and situation when you're trying to figure out if you're undercharged or if you're overcharged. But within the calculator, they've worked it to where you don't necessarily need that number, but it certainly does help. So when looking at a system, we want to make sure we have the right tools to get this information. So clearly, I want an accurate set of gauges, and whether that's analog or they're digital, just make sure that they're accurate. Maybe when you're using digital, make sure they're zeroed out before you throw your gauges on, because we want to make sure that we get the most accurate information with the tools that you have. So yeah. Start from the top. We need accurate set of gauges. Also too, with the new charging calculator and along with the new charging charts that we'll take a look at, the biggest thing that we require in tech service is a indoor wet bulb, and that is done via a psychrometer. So I highly suggest that the guys in the field have psychrometers to get the indoor wet bulb, because if they don't know the indoor wet bulb, then the guys at tech service were guessing, which is not going to be accurate as it should be. So the biggest thing is we need a digital psychrometer for the best accurate measurement on that. Also too, we need a digital thermometer and a charging scale. So on that, make sure your charging scale is an actual refrigerant charging scale. You'd be surprised what we find out over the phone sometimes. But also too, just those are the tools that we're going to want to need to get information to put into that charging calculator to help best you guys determine what's going on with the system. I kind of touched on this a little bit ago, but the big things that will affect your charge is going to be, one, your ductwork. So that is just when you get to the unit, that's an automatic visual thing that you want to take a look at and see what you're up against on the ductwork side. So, you may be just fine, or you may be room for improvement, if you will. So just things that will affect the numbers on that calculator are some of the following. So ductwork, also too, take your duct static pressure. If you think your airflow is off, or maybe it's less than what you think it is, take a duct static pressure. So generally in tech, we go off of a 0.5 for a duct static pressure if the guy in the field doesn't either have the tools to take a duct static, or if he doesn't know. But really the testing data that we have goes up to a 0.8 on the duct static, which is high. I would say, anything that would be 0.7 or more, you have room for improvement on your duct static number. Also too, your blower speed, that's going to be a given on, especially if you have a piston driven system. the airflow going across that indoor coil is going to affect how your charge looks. So just make sure your blower speed, again, is set to where it needs to be. Also, too, return air filter. That's another one. Just make sure that's clean, or just inspect that at the very least. Make sure you're good there. And another thing you guys want to check is the delta T on the system. Basically, what I like to look for over the phone is going to be anywhere from about a 17 to a 21 degree temperature drop going across your indoor coil. Why do I want to take this reading? Well, you want to because it's going to help, get you back on track for your cooling side. So, if you got a 20 degree drop going across your indoor coil, I'm cooling the space pretty well. Now, you also want to double check your readings, but the delta T just helps you prove that I am indeed cooling, and that you're at least on the right track to getting the system properly charged. So let's take a look at two examples on the charge calculator and see what we got going on. So first thing, when we get to the charge calculator website, again, it's just chargecalculator.com. Once you get to this website, the two things that we ask for is just your zip code and email address. Once you do that and hit sign in, it'll kick you over to the charge calculator. Also, too, this icon here, we put a PDF file. If you click on that link, you'll get a PDF file. And basically, what we're looking at here is just a simple way to get the charge calculator on your home screen, and basically the best way to access this this tool, because it is a web-based app. It's a web-based app. So, but basically, whether you have an Android or an Apple phone, it will just go kind of step by step on how to get this on your phone and how to get it on your home screen. So that's just a good way to look at that. But once we put our zip code, email address in, it's going to kick us over to our charge calculator. So what we got here is variables that will punch in here, and obviously this will be based on whatever system you're working on. So just the first one here, what type of system? This is where you select, based on your coil technology, whether you have a microchannel on the indoor or the outdoor, and tube and fin, vice versa. So basically what we'll do for our example is we're just going to try to keep it simple here. We'll go straight AC with microchannel indoor and outdoor. And then for control type, you basically select whether it's TXV driven or if it's going to be piston driven on that. So for our example, we'll choose TXV. Tonnage, we'll kind of go right in the middle at 3 ton. SEER value, we'll go to 14. The next one is going to be your vapor line diameter. So, whether we're having a 3/4 or a 7/8, you just want to make note of that. And again, this is where just knowing all this information is going to help, direct you to your proper charge. So once we kind of start scrolling down here, if you have a longer line set length than 15 feet, this is where you would enter that number. The condensers come pre-charged for 15 feet worth of line set. So just by default, we put 15 feet in there. And then also too, here are some other things down here at the bottom that you can put in. Basically, the thing I want to highlight is this box here. So this is where you would put the charge number in if you knew, based on your model number, what the factory charge should be. So if you don't know that, that's not a huge problem. Basically, all you'll do is just calculate base charge. And once you do that, it's going to kick you down at the bottom here. And you got a couple of slider bars on this. One, you'll have adjusting your outdoor ambient temperature. So what the outdoor temperature is. Also your humidity level. And the big one is your indoor wet bulb temperature. So, I mean, I can move this pretty much, anywhere that you want to, but for example, we'll do about 95 degrees outside, and we'll just leave this roughly where it's at, or we can do it a little bit higher. So once you kind of know based on what type of day it is, you'll put that info in here, and then you'll hit start timer. Okay, so the next thing is going to be what are your pressures and your line temperatures going to be. So, for example, our liquid pressure will be 450. Liquid line temp is going to be a 105. Suction pressure is going to be a 125. And suction line temp is going to be 55. And once you hit calculate charge, it'll give you a percentage in the system. So just right off the bat, based on our tonnage, and we didn't necessarily know what the factory charge was, it's telling us that we've got almost 8 ounces of charge that we need to recover. And also on this bar, we've got a percentage number as well. So we're basically 111% of the charge level. So we're, basically 11% overcharged. So also as well, it'll give you a subcooling number because our system is TXV driven. So it gives you that as well. If you scroll down, you'll have your pressures and line temperatures. So this is where you can adjust the number. If the system is changing, if your head pressure goes down, your liquid line temp goes down, that's when you can adjust the charge. And then if you hit recalculate, it will then change this number up here. Also too, it'll give you a superheat number of roughly where we should be at. So if you were to take your superheat, we should be at about a 12 degrees of superheat, which is right on the money. That's what the TXV should maintain, is about 10 to 12 degrees of superheat on that. And also too, this is where you can adjust all of your outdoor and indoor settings on that. So that's basically the charge on that. I mean, if you hit start timer, all this is just a clock, if you will. So, with 410A, you want to give it at least 5-10 minutes. I look for around the 10-minute mark, whether you take out charge and then rerun your numbers or add charge and then rerun your numbers. So, the timer is there just for a convenience factor. It's not going to prevent you from changing anything on that. So it's just for a visual as far as that's concerned. So that's kind of an overcharge scenario. And then what we'll do on the next one, just so I can let you guys take a look at this. We'll do another one, split AC with micro channel. We'll do TXV, 3-ton, 14 SEER, 3/4. We'll leave it at 15. And then let's say we still don't know what our charge level base is, so we'll hit calculate base charge. And then let's kind of change this up a little bit. So let's say it's about an 80-degree day. And let's kick this up a little bit. We can do humidity level. So you can hit start timer. It's going to kick you over. It has at the top here 15 minutes, but you certainly don't have to wait 15 minutes. So again, that's just a point of reference, if you will. But we'll put in some pressures here. We'll say 265. 87 degree liquid line, suction pressure. Let's say it's 115. Suction line, let's do 3, calculate charge. Okay, so based on those numbers, what we've got here is we're under charge. So we've got 77% of the charge needed for this system, if you will. So it's telling us to add essentially 10.5 ounces of charge for this scenario, and needs us to check subcooling on that. I'm not sure why my subcooling is at 0.53. Let's see what we did here. Oh, so yeah, so subcooling, basically we have one degree of subcooling because we're under charge. So the superheat number that we have here is a 24. So, you know, with that, we're underfeeding the evap coil with that TXV, which by default is going to raise our superheat number. But again, like all of these variables here, you can change, and all of the bulb tempers you can change as well. So basically, that is just a quick rundown of the charge calculator. I know that we did a video on the charge calculator a little more extensively with the web-based version of this with your phone. That can be found on EdgeTech, and I know like Doug and Greg did that one. It's a very good video to take a look at. So they go over a lot of the things that we did cover, but again, I just want to bring this to your attention that we have this tool available for you guys in the field, and it's very helpful to at least get a baseline on this. So, you know, whether you're commissioning a system and starting up a new one, or if you're coming up on a system and want to know where you're at from a charge perspective, it's a good tool to use. So the next thing that we're going to take a look at are the new charging charts. Let's take a look. So again, with the new charging charts, you will have a variety of different ones depending on whether you have an AC or a heat pump, you know, and the model number will also determine how many charts that you may have. So, you know, because we'll be charging in cooling mode, and then obviously if you have a heat pump, you'll also, you know, have a heat mode, if you will. So it'll be a lower ambient temperature, but let's take a look. So just to start off here, the process of this has changed a bit. One, we will always charge in cooling mode. So even if it's, you know, 40 degrees outside and you got a heat pump and we're trying to charge this thing, we're always going to be charging it in cooling mode. We'll get into that in a little bit here. But just to start out, always charge in cooling mode. Again, this charging charts that you'll see in the field is only going to be for the split systems. So your 13, your 14, and your 16 SEER models will only have the new charging charts in them. So again, this isn't across the board change or rollout, if you will. It's just going to be for those types of models. The charging information can be found in the install instructions on page 9. So when you go to the install instructions, when you look at page 9, there'll be kind of two sections there. One will be if you're in cooling mode, and the other one will be if you're, you know, when I say cooling mode, I mean like, you know, middle of summer when it's 80 degrees outside, or if you're in the fall or winter time when it's colder out, say it's like 40 degrees outside. There's kind of two different ways to go about doing it. Majority of the time it's going to be the same, but we'll just take a look at that. Also too, the AC models have they may have one or two labels on the indoor panel, you know, because that'll determine, again, the model on that. So like, for example, if you had a 16 SEER AC, you won't have a piston on your indoor evap coil, and you'll just have like one chart. If you had a 14 SEER air conditioner, you may have a piston or you may have a TXV on the inside, and that's why you'll have two. The same kind of principle applies to the heat pump, except what you're adding to that is the charging portion when it's cold outside. And we'll take a look at a chart here, but basically, depending on your heat pump model, you may have 2 to 4. So you may have a total of 4 charging charts on your heat pump, and that'll kind of determine what your indoor metering device is and what you'll look at. So also too, for a heat pump, if your outdoor ambient is between 60 and 35 degrees, half of the condenser fan motor needs to be blocked off with something, whether that's a piece of plywood or cardboard or something like that. We're just raising the head pressure in order to charge the system accurately. So that's when you're in the fall or winter time, when we're trying to charge a heat pump. So again, half the condenser needs to be blocked off. Also too, the inverter split units, our BG line will not get this charging chart application. So we're still going to go off of the charging curve on that. So just keep in mind, this doesn't affect the inverter splits. I just wanted to point that out to you guys. Also too, the package units will also get this charging chart eventually. They're working on it currently through testing and stuff like that. So, in time it will roll out for you guys on the package side, but currently it's just for the split systems again. So what I've got here is just a picture of what the new condenser panel on the inside will look like. So, obviously we have our wiring diagram, but this is going to be a heat pump because we have 4 stickers on it, and it's probably going to be a 14 SEER. I'm not 100% sure on that, but it's probably a 14 SEER because we could have a TXV or a piston on the inside. So again, this is what it's going to look like, and these are on all of our new condenser models on that. And then the next couple of slides, we'll just kind of take a look at what those labels look like if you guys aren't familiar with that. So this is for a heat pump application, okay? The reason right off the bat why I know that is because on the very end over here, we have 35 to 60 degrees for our ambient temperature. Obviously, that's going to be for a heat pump application. So we're not running an AC, or we shouldn't be running an AC under 60 degrees. But on that. Now, one thing I really want to point out to you guys, which we kind of touched on in the charging calculator portion, is the indoor wet bulb temperature. So this is where we really have to know what the indoor wet bulb is, and the techs need to have a psychrometer for us to properly charge this. Most manufacturers, HVAC manufacturers, require an indoor wet bulb for proper charging. So, again, that's just a vital tool that the techs need to have in their arsenal when they're going to troubleshoot an HVAC system, especially our equipment, that we're really requiring an indoor wet bulb, because based on what that wet bulb temperature is, it will determine what the superheat number is. So just kind of at the top on here, so this is an Orifice system. So with an Orifice driven system, we're going to be looking at superheat. And again, this is in cooling mode. So it may be, 40 degrees outside, but we're going to be running this heat pump in cooling mode, and this would be as if we have an indoor piston on the indoor coil for this charging chart. So a couple things, just to recap. One, we're always doing this in cooling mode, and with piston-driven systems, we're going off superheat, not subcooling. It's always superheat with piston. which are these numbers here. And again, we get that based on what your indoor wet bulb is and roughly what your outside ambient temperature is. So, so that's that. The next chart we'll just take a look at here is for a TXV driven system. Again, on all these charts, the indoor wet bulb is going to be at the top. So that's something that we're going to have. This is for cooling mode application. So from 60 to 115 degrees ambient temperature is what we're looking at here. And these numbers will reflect a subcooling number. So, you know, if it's 75 degrees outside and we've got a indoor wet bulb of about 61, so we should be at about 11.6, 11 to 12 degrees of subcooling on that. So that's that for the TXV for like an AC, for example, for the TXV on the indoor. And again, this next chart here is also for cooling, 60 to 115 degrees ambient. And you just want to know what you got on the indoor for your metering device. This is going to be for a piston-driven system, which is going to be superheat. So these are all going to be superheat numbers. And, you know, it says restrictor at the top. It's piston-driven restrictor, same thing on that. So that's kind of what that sticker looks like. And then this document here is not available to you guys yet. It's still in the process of making its way onto the literature library. Because what we wanted to do as well, and it may be hard to see on the screen, but at the top, on the very top corner, we have the model number, and this is just a straight AC 1.5 ton model number. But what this will give you is a target subcooling, a target superheat. It will also give you pressures, kind of based on your ambient temperature. And at the top here, what your indoor wet bulb is. So that's what that number is going across the top. And then your outdoor ambient is going to be these numbers here. But this type of information is kind of similar to our original charging charts that you found in the install instructions. But we're going to put this type of stuff in a separate document on the literature library, just so it's a little bit easier to get to and you don't have to scroll through all the pages of the install instructions to get, you know, to what you need. So again, the engineering side and the marketing side, we're working on getting this out to the literature library. It will be available to you guys for troubleshooting. So just real quick, the TXV driven and the piston driven stuff will be similar charts. Just at the top, it'll say whether it's TXV or if it's piston driven. So like, for example, this again is in cooling mode, and it's a TXV driven indoor coil. So it's a little more in depth, you know, from a pressure standpoint, because a lot of guys still go off of pressures and they want to know roughly where my pressure should be. And, you know, they may not totally go off what a superheat or a subcooling number is. They want to know if their gauges are, or at least some, you know, some are close where they need to be. So again, that's that for the supplemental charging chart. That's what they titled it as. But I just want to appreciate your guys' time in this. Again, this is the first out of 2 technical service lunch and learns that we'll take a look at. And you know, the biggest thing was the new charging charts that, you know, are rolled out on the units, and how do we apply that to the field. So with that, hope you guys have questions for us, and let's see what you guys have. Thanks for watching, guys. So far, we've got a lot of great questions that have been filtering in through the video. We're just going to take a look and see what you guys have questions on, and what I may be able to help you with per the Lunch and Learn. So let's just kind of dive in here and see what we got rolling today. So first question here from Scott. Scott is wondering, basically, can we, I'm sorry here. Scott. Okay, so Scott is wondering, so the slider that is on the charge calculator, he's referencing that it may be hard to use that slider for the temperature reading for like your outdoor ambient when changing that, or if you're changing like the indoor wet bulb. I know there's like 3 different sliders that are in blue on the charge calculator. So he's just basically saying that sometimes it's hard to use that slider on a phone, and maybe if we can have a number punch in, if you will, instead. To my knowledge, that is the only way to use, to get the number for your outdoor ambient or your wet bulb. We have talked about that before. Instead of using the slider and maybe using like what looks like a calculator, if you will, to punch in the number. So we've talked about that before. That'll be a suggestion that I'll put in to where we can put that on the calendar and see what we can do on that, and see if we can have that updated per the charge calculator. So good suggestion. I know exactly where you're coming from, because sometimes it's easier just to type in a box and then type in a number instead of trying to find it on your phone. So I get it on that. So we'll see. I'll put that in the request and see if we can have both, if you will. Let's see. Got a question here from Jerome. Jerome is asking, are we ever going to make this into an application for the App Store? To my knowledge, no. Currently, it's just going to be a web-based app. Again, if you go to thechargecalculator.com, on that homepage, like it was earlier, there is a PDF that you can download to put a shortcut on your home screen. Currently, it's just a web-based program as of right now. I don't know of anything in the works on making it a app per se, to where you would go to, the App Store or the Google Play Store and download that. I don't know. I can put that in the suggestion box as well and see if that is something we can work on. And, if a lot of people are requesting that for just a ease of application, if you will, that will probably be the driving factor in that development. But as of right now, it's just for the web-based portion. Got a question from Tom. Tom is asking, in regards to subcooling on a TXV systems is not recommended. So he's basically asking, is subcooling using for a TXV? So yes, you're right. The answer to your question, if I'm reading that correctly, is that if you have a system that is TXV driven, you will use a subcooling method. Just remember, subcooling is for TXV, and superheat will be used for a piston or a Orifice driven system. So if I got that right, yeah, so TXV is for subcooling on that. So when you're looking at those new charging charts, you're going to be looking for the subcooling number on that for your new charging charts. Okay. All right, so another question from Mr. Jerome here. Can we use the calculator for heat pump mode? So the calculator is only for cooling as of right now. I'm not sure if they're going to be doing a heat pump mode application scenario, but it's only for cooling. Also, you can block the condenser off in cooling mode down to a 35-degree ambient temperature. So that's what I can kind of say on that front for like a charging mode application to see where you are for charging. Just also remember too, I meant to bring a sheet in here for you to take a look at, but on the new install instructions on page number 10, there's a diagram of a condenser, and we just advise to put to block off the top half of the condenser when we go to charge that unit up in cooling mode. If we're in the middle of October, if you will, and it's cold outside. So again, per that question, it's only for cooling mode. All right, let's see what we got going on here. Yeah, so just another point for the application based. I completely understand, because in some cases you don't have internet access on your location for your job site. So I completely understand on that, Scott, where you may want an app-based application to where you can use it if you don't have internet access out in those rural communities. So I totally understand that point there. That's something that we've kind of talked about in tech, on guys that are more in the rural areas, rural farming community areas that, may or may not have enough, bandwidth, if you will, in order to run that app. So it's a very valid point, and again, I'll pass that along as well. A lot of good questions, guys. Keep if you have anything, please send that in here. I'll be happy to answer it. Another question that came in is, can you use the charge application app like for a restriction type scenario? Not necessarily, because when you have a restriction scenario, your pressures and maybe your line temperatures will reflect that kind of troubleshooting aspect. So it's not really for if you've got a plugged filter dryer, for example, or maybe you got a piston or a screen that's got some debris in it. The charge calculator is good for either commissioning a system to see where you are and if you need to add any additional charge per your system matchup. It's also good to get a straight baseline if you come up on a system and you're not sure where you are currently, and you want to run those numbers through the charge calculator. It's a good starting point to see where you're at charge-wise on a system. So good question. Let's see here. Okay, so Mr. Michael's got a question here. His question is in regards to setting dip switches on the 90+% furnaces and the 80% percentage furnaces that would have to be set. So yeah, so per your question, and this also applies to the air handler side. When you do have an ECM motor on the indoor, you do have to set the dip switches. Now, obviously, if you're this rule would apply to both the 80 and the 90. So like the G7 SA model is a PSC driven motor, so those have selector switches that are on your board. So with a PSC motor, you're only going to have one board instead of two boards. And on, for example, like the G7 SC model, which is the 92%, the SD model, which is the 95%, both of those are single stage furnaces, which will have PSC motors in them. You do have to select the selector switch for your blower speed for everything that's basically two-stage related, which could be the two-stage 80% furnace along with the two-stage furnaces as well, you do have to set your dip switches because those are not factory set. Just remember that. Also, everything that PSC motor, whether that's the air handler side or your furnace side, is also not PSC or is not factory set. So, because basically we don't know where that unit is going. So you want to make sure you set your dip switches, which if you don't know where those are at, those are found in your install instructions, which if you don't have that at the furnace, you can get that through the literature library through our homepage, which is nortechhvac.com. And there's a technical literature tab at the top right corner. You can select that, and that will you can get the install instructions that way. Let's see here. A lot of good question, guys. Please keep them flowing in here. Okay, so another great question. Hector is asking a question in regards to the indoor unit and the outdoor unit. I'm wondering if they are a matching system or not per the AHRI match. So great question. So the easiest way to know if your system is matched properly, obviously this is only going to apply to our equipment. There's a couple different avenues that you can take. The most easiest one that you can do is go to the technical literature library on our website. If you view it from your phone, it'll be more on a mobile-based platform instead of a web browser as if you're on a computer. But if you access that through your phone, after you select North American products, the brand that you're working on, there should be a link there for the AHRI information, or it's AHRI matchup. I forgot the actual the wording on it, but there should be a link there for you. So what you can do is if you hit that link, it's going to download the AHRI match file. That file is from us, which gets updated every couple days just to make sure that we have it the most up to date. So at the very top of that document, it should have a date when the last time it was updated. But to know if your system is a proper matchup, you can either look at the QRD, which is also on the tech library, or you can go through that link, which will download a separate document to your phone. Once you do that, you'll basically have a couple of drop-down arrows to determine what equipment model number you're working on, what the indoor is. It'll tell you the SEER rating on it, the CFM that it was tested at. So that can be viewed certainly through the web browser, but it should, I believe, also be available through the mobile version of that as well. But certainly on the web, like if you're on a computer, it definitely is there for sure. Okay. Yeah. Let's see. Matthew's got a question. So when you're going through the setup on that calculator, his question is in regards to the humidity slider. So on that, there's two. There's one for the humidity, if you will, is the outdoor humidity level. That would be like if you had like a weather app on your phone, it should give you like the humidity level of where you're at. That would be the easiest way to figure that one out if you had like the Weather Channel app or like, the weather app on your phone. But yes, per your question, that would be your outdoor humidity. And then the third slider should be your indoor wet bulb, which you'd want to take with a psychrometer, again, which is very important with the new charging. Is that you need to know what your indoor wet bulb is in order for this to be the most accurate that it can be. So yes, your humidity is your outdoor. Good question. A lot of good questions here, guys. Let's see what else we got going on here. Let's see. Okay, so Robbie is asking here, will this work with microchannel and tube and fin match systems? Yes. So at the very beginning, when you're actually setting up your system, if you will, where you're picking your coil technology, that's like the first thing that you pick. But yeah, the example that we did today was with microchannel to microchannel. I just kind of wanted to keep it simple there for you guys, just as a quick rundown on what that is. But yeah, so if you hit that drop down arrow, it will give you an option for like an indoor tube and fin with microchannel outdoor. Or actually, I said that backwards. It'll be well, yeah, no, it would be that. So like a microchannel indoor with a tube and fin outdoor, or vice versa, along with a microchannel indoor and outdoor. So yes, so that's like the first drop down when you select like your tonnage, your SEER, and what metering device you've got on your indoor unit. Let's see, a lot of good questions, guys. Let's see what else we got going on. Okay, so Robbie's got another question here. So I believe what he's asking, he's asking in regards to the QR code. I don't know if that is the QR that's on the charging chart, or if that is for, because we came out with a new sticker that's going to be on the on all the new service panels. It'll be red text. It'll have a QR code on it. That will shoot you over to the charge calculator. I'm not sure, Robbie, if that's what you're talking about or not. That's on what would be the outside portion of that. Also, kind of a quick note on that. If you have an iPhone and you go over a QR reader code, just open your camera function app and it'll take you right to the link. If you have an Android phone, you'd want to make sure you just download a QR reader code from the App Store. Let's see here. A lot of good questions, guys. Okay, Dana's got a question here, Mr. Dana. So what Dana's asking, which I believe is what Robbie was asking, maybe it was something a little bit different. Dana's talking about at the bottom of the charging chart, there is a QR reader layout, if you will. And what that should take you to is the charge calculator on that. So that's also another way to get to the charge calculator, is if you take your phone, whether Apple or Android, it doesn't matter, you go over that code, it should shoot you right over to the charge calculator. I'm pretty sure that's what it is. The only other thing I could think of is, because I'm getting that mixed up with a different QR code in my mind here, is that it would take you to the either the tech spec or the install instructions for that unit for the charging portion of that. To be honest, Dana, I'm not 100% sure on what that little QR reader code is at the very bottom of the charging chart. I'm pretty sure it's for the charge calculator. If it's not that, then it should give you a link for the actual unit. That's something I can follow up with you on, though, and and see, and I can double check with some people on that. I'm just not 100% sure as far as that, because it's very small, I believe, is what you're talking about, in the corner of that sticker. So, good question. A lot of great questions, guys. If you have anything else for me, please send it in, and I will be happy to answer it for you. But I hope that today's presentation was a good, at least starting point of understanding what the charge calculator is, what it's there for. It's another tool for you guys to use in the field for troubleshooting. And we do have some more videos on the charge calculator. This isn't the only one. Doug and Greg did another video that's through Enora. I think it's about like 10 or 15 minutes long, where they're in front of some of the units that are in our lab, if you will. And Doug goes through like a step-by-step process through the actual mobile portion of that. And that's another great video to take a look at, and just for reference, just so you guys know the full capabilities of the charge calculator on that. The other thing I wanted to point out is just the new charging stickers on there. So, we used to have it to where we had just a huge table sticker, if you will, that was on the inside panel, where we would give a temperature and a ballpark of discharge pressure, suction line pressure, that kind of stuff. So again, what engineering has been working on for a while now is trying to go for more of a ballpark scenario, more down to not an exact science, but more down to a number that's realistic that you can shoot for. Again, also that supplemental charging chart that I want to let you guys be aware on, that is not yet available on the literature library. It will be. I don't actually have an exact date on when that's going to be available, but again, it was that document toward the end of the presentation where it was kind of hard to see the text. That's where we'll give you an actual pressure temperature relationship in regards to superheater subcooling. Because I know some of you guys in the field, you still want to see a target pressure, whether that's the high side or the low side, and versus just going strictly off a superheat number or a subcooling number on that. So that's something that will be available to you on that. But yeah, if you guys don't have anything else for me, I appreciate your time checking the video out, checking the Lunch and Learn out, and I hope that what I gave you guys was something that you can take with you into the field, just to try to make your day-to-day just a little bit easier for you in understanding that. Again, if you guys have any questions on the stuff we covered, feel free to either give us a call into tech service if you're working on a unit and you're using the charge calculator and you have a question, or if you have a question on the new charging charts that you guys will see here in the near future on some of the newer equipment that's going to be coming out. Make sure you guys, if you have any questions, let us know. But yeah, this is one of 2 Lunch and Learns that we're going to be doing for tech. Later, we're going to be doing, I believe, like the top 5 tech calls in for spring. Either myself or Doug will be doing that video with you guys, or we may be tag teaming that subject. So again, appreciate you guys' time into reaching out to us and looking at our Lunch and Learns. It's most appreciated, at least from tech, just the time that we go into it. But hope you guys have a great spring and a great summer, and we'll speak with you guys soon. Thanks.